Hello, I'm MC Toon, the worst rapper in the world. Good evening. Tonight we have a very special guest. I have with me a fellow Minnesotan, EftupWorld. How you doing?
Good. How are you doing?
I'm great. Do you mind? Should I call you EftupWorld, or do you mind if I go with your?
Call me Joe.
All
Call
right.
me EftupWorld.
Joe,
Call
all
me Goofball. I don't care.
I like being personal as long as you don't mind.
Is it Michael or Mike? Or MC?
Both.
Or all three?
I get everything. I get Toon, MC Mike, Michael. I get MC Goon, MC Tool,
Okay,
MC.
that's pretty good.
MC
Cartoon.
Yeah, Mac Cartoon. I've gotten Mick Goon or Mick Boom. That was my favorite.
Boom.
Because I'm like,
That's a good one.
how's that an insult?
Yeah.
Worst insult ever. You got to try harder.
There you go.
So, we don't have a particular schedule or anything, but I would like to show this first. I ordered up some sample mugs. Let's see. It's not going to focus because I have my camera on fixed focus, but right there, Toon on one side. On the other side, it says your inability to grasp science is not an argument against it. And then I've got the Mark Steele's version that says here, ionization is when you knock an ion off an atom. That is absolutely wrong, but that's what he thinks. The very, very expert Mark Steele says that. And then on the back's the other side here, it has his saying that's the 5G death ray lamppost that tried to get me. And then a little thing underneath saying it's got a directional microstrip, high gain scanning, target acquiring radar antenna. Citation needed. So there you go. Both available on my this one. I'm not sure. They complained about it because, obviously I didn't get my own version of the Grandpa Simpson thing. So they complained about it. But the other one is on my Teespring, which is linked in the description and in the live chat here. So there you go. How are you doing, Joe?
I'm doing good. I was just pulling up a picture here. I don't know if, whoops, wrong one here. I was going to see if you saw this picture. Where is it? Right here. Yeah. Have you seen this? They just figured this out.
Oh, yes. I've seen that before. That's amazing. But I thought there'd be a little more snow and ice.
Well, it's warm, I guess. I mean, it could have just been dry season,
Dry season.
The crops behind there. Yep.
That's nice. So, you were on with FTFE and Res Rhetoric a week and a half ago and you talked about that you think that we did go to the moon and that satellites in the ISS are up there somewhere.
Well, do you want me to try?
I'd love an explanation. While you do that, I'm going to open up my pickles that I made myself.
Okay. So one interesting thing with Toon here, I'll call you Toon, is that you've mentioned that you met Charlie Duke before.
Yes.
And that's an interesting aspect for this conversation, I think, because I personally don't believe. I used to think that there were people lying to people, like NASA or space agencies, I guess.
Yeah.
And then more than that too. But I've learned that is not the case. And Charlie Duke is a good example of how I can explain it. Now I don't know how good Charlie Duke or something, but what I'm saying is you believe what he said, right? He's not lying about something.
Yeah. He spent the last several years of his life as an evangelist. That's what he does now. And he's done that and used his astronaut status as a way to bring people
spread it further. Yeah.
So for the whole, because there's a lot of flat earthers that say the Bible says it is flat. And so that kind of doesn't sit well, you know, that.
Oh, I totally hear you.
Right.
But if you understand, and hopefully I can get, you know, the point across, or at least get you to understand where I'm coming from. Okay, if God created the world, right? Created everything, the universe and whatever, all the things we see, and everything here, and us and everything. If that's the case, and he was going to send, at some point in time, send a strong delusion, how strong would it be? That's all I'm trying to say is the scope of that delusion or whatever would be probably pretty big if he's the God of creation, right?
If he made everything and then designed it so that we'd be confused about it.
No, not designed it that way. Gave free will to a bunch of angels and a bunch of people like us, and then you know, I know this is probably not like where we want to end up in the whole that side of the story, but as far as what Charlie Duke, I believe that Charlie Duke saw the things that he says he saw, and he went to the place that he said he went. But I think that that place that they go to go to the moon is being for our generation doesn't see it the way that it may be. And I'm not saying it's fake or something like that. I think that it's a place where there's purposeful deception, but it's not people. It's not like it's not a NASA astronaut pretending he went to space. It's they're going there. They're going to this place, right? If we call it space, we call it space.
Yeah, space. The technical definition is just anything above 62 miles or 100 kilometers.
And actually, that's something
that
that's
exists,
something,
right? There's really no question about that.
And that's actually something. Oh, go ahead. Sorry.
There's maybe some flat earthers that think there's a firmament lower than that, but
and the way I understand
consistency,
the way I understand the firmament is it's like it's a place of darkness, because in the beginning, God created. You know, there's darkness upon the face of the deep, and then he divided the light. He said, "Let there be light," and then he divided the light from the darkness, and the light he called day, and the night or the darkness he called night. So it's simple. I mean, it's just the absence of light is darkness, right? And I think that that's what we may be misunderstanding is what that darkness is.
The problem is they calculated the necessary things to orbit the Earth. They calculated the necessary distances to go to the moon, and then they applied the rockets so that it went that far. So for it to be somehow inexplicably not as they think it is, it acts exactly as they think it is. That's quite a stretch. But here's the thing. What it seems to me is that you start with the conclusion it's flat, and then let me try to shoehorn things into it.
Well,
that's what it seems like.
I think it's kind of two different topics. I think the flat Earth, that's a topic of the ground, and the moon and space and all that is literally a topic of the sky. Like two, you know.
Think there's like some transition place?
I think that it's the end of where the air ends.
There's no place that the air ends, though. It's
the Kármán line with the generally. I mean, you can let me grab a video here just to show you kind of what I'm talking about. You've probably seen this. It's really cool footage from the ISS of it's ESA, I think. Let me see. It's a a Soyuz launch. See if I can get that in the background. Get me out of the way a little bit. You can see it here. I'm not saying specifically, at what mile it is or something. I'm saying there's a general place where the air's not really where it stops. The atmosphere generally stops.
Well,
and then it thins out drastically.
It gets thinner and thinner, yeah. The biggest change in pressure happens near the surface. At the
You're
greatest
saying
rate.
Like down by us.
Down where we because when you get to if you look at the balloons, like there's a balloon sent up by flat earther Dwayne Kellum, and he has a barometer on it, so he sees the pressure, and at about 100,000 feet or somewhere in that area, it's at 1% of the pressure of what it is at ground level.
Yeah,
that's just at 100,000 feet. There's a lot longer distance to get up to where the ISS is, and you've already lost 99% of the air pressure. There isn't a whole lot more to reduce.
Yeah, that's kind of what I'm saying is where okay, there's air, and like I guess up by the Kármán line, you're not going to be breathing air like without you'd need a
and in an airplane you need
pressure.
Yeah.
You need because it's anyway. What I'm saying is when the air stops. Oops, I'm back over here. When there's no drag on a vehicle, how high is that? Or not, and I don't mean no drag, but like
there's never technically no drag, but where is it low enough that you can effectively treat it as zero drag?
Or
I don't know.
What can you can't reach orbital velocity through the air, can you?
With like an airplane
or a rocket?
Well, if there were no air,
Well, I get we have to be more general because I'm not trying to be as technical maybe as you're used to with, because I know you have a lot of
let me say that this is an interesting thing going back to Charlie Duke. He mentioned and I knew this in my head, but I hadn't thought of it. He's like, on the moon, since there's effectively no air, you can orbit at any elevation as long as you don't hit the surface features, where you can't do that on the Earth because the air will slow you down quickly.
Yeah, it would be a completely different thing.
So you can potentially orbit at above the Kármán line as long as you're constantly, increasing your.
You just have to be at the right velocity to have that.
Keep increasing your velocity, yeah.
And then it would be like your outward acceleration would match with the gravity, and then you'd orbit, right? I think. I don't know if that's the right words.
The air slows you down, and that's what messes up your orbit. The ISS needs to occasionally increase its they call it delta V, or it'll boost itself because there's a little bit of drag.
Have you seen a video? I think it was Jeffrey Williams. When they were doing a burn with the ISS to get it to raise it up a little bit, he demonstrated it inside the ISS with one of his cameras.
I've seen it, and then like everything goes to the one side.
It was like, I don't know how long, like it had to be a minute long or something like that. So he was kind of playing with it, and it was you could see the change in velocity. But so I guess we could say this. Okay, in order to be in space, I mean, we could fly something straight up in the air and get up to go 300 miles high, but we're just going to come right back down.
Yep.
You have to have that horizontal velocity. Well, what is it? About 17,500 miles an hour just to have an orbit, right?
It depends on your elevation. It's completely dependent on elevation. That's about
the lowest that's about, I think, the lowest that we have anything orbiting, right?
I don't know. No. The I'm pretty sure that I guess I don't know that for certain, but the the satellites that SpaceX has been putting up for communication are in a low orbit too.
But they're in a high, they start out in a lower orbit, but they climb up to, they're higher than the ISS. Not right when they launch. When they launch, I think they're even under it. I guess if that's the right word, under. But so here's maybe an example. Okay, so when Charlie Duke went to the moon, they launched on a Saturn V, right?
Yep.
And
got it right behind me here.
Yep. And all the stages goes through all the stages, and then they're on the way to the moon. But they're in 0G, right?
Yeah, they're not experiencing.
Yeah. Because they're technically, the way that you would understand it, or the way I would understand it, that I think you would understand, is they're orbiting the Earth, though. So that's why they're in 0G. They're just moving at a much higher velocity.
Well, yeah, when they were on the way to the moon, I don't know. I suppose you could say they're orbiting because they're.
Well, they would have to be to have. Well, and that's kind of what I'm going, or where I'm going in my mind is 0G on the ISS. It requires curvature.
Yeah.
Low Earth orbit requires curvature, right?
Yeah.
And that is where I think that there's something to look at, because as far as, okay, I'm not saying I know what the difference between like the spiritual realm or you know, and I know a lot of people don't believe in that, but the celestial realm or whatever, that realm and the Earth, I see as two different kinds of natures, two different places. And I didn't see it that way before. And I think the firmament, okay, let's put it this way. The ISS almost orbits without any fuel, or like without any propulsion. We propelled it once, and like you were saying, it degrades or whatever, or I don't know what the right word is. It slows and goes lower a little bit, and then they can boost it every once in a while.
Yeah. Ooh. He froze. He was having network issues. He had to reboot his. Oh, there, you're back.
Oh, was that me?
Yeah, you popped out for a second there.
Okay, sorry. Yeah, I your video went it froze, and I was like, uh-oh. So that must have been on my end, probably.
One of us, yeah.
So free fall on the way to the moon and free fall on the way back from the moon.
Yeah.
Right? Okay. What I'm saying, I'm trying to like bring into the conversation that the physics, although we can say, you know, like with gravity, we can see the moon's orbiting Jupiter, and we can like you were saying, they have to plan their trajectory just right to meet up with the moon, and to all the to go anywhere. You can use all these physics that we have here on the Earth. They work up there, right? You'd say that?
Yeah.
Or they appear to? Because
I wouldn't say they only appear to.
Okay, good.
Yeah.
Good. Okay, and so that's where I want to like kind of challenge you on some of these things. So if we're thinking of anything that's ever been outside of the Earth, in that place up there, space or whatever you want to call it, is moving really fast, right? I'm just saying, has anything ever just fallen down into the Earth? Or was it moved? It had
a lot of satellites there. They bring them into intentionally reduce their orbit so they
burn up,
and they tend to dump them in the South Pacific, where there's not a lot
what's left of them,
not a lot of and so if anything gets to the surface, there's not a lot of islands or people around to get hit.
But every single one of those that they are done with, and they basically drop back down or whatever, those, how fast are those moving?
Really fast. Yeah,
really fast. So what I'm saying is, there's a world above ours that we can go up as high as we want into it, and not really be affected by it, because we could fly a rocket up 350 miles and it's just going to fall straight back down, right?
If you don't get the lateral
Yeah,
velocity.
you need that horizontal or that sideways velocity so that you can fall, like, so that your outward acceleration, and I'm only using these words because that's how we've understood it, is that to find that 0 g, you gotta be going just fast enough where you're not going to be losing altitude, or not gaining altitude, so you're just kind of free falling, right? So the only way that we can do that on the Earth, that we can mimic it, is like in a jet for just a very short amount of time, doing those dives, the vomit comet or whatever they call it.
Yep.
Okay, so that's a big difference between that place up there and the Earth down here. Now, maybe the physics apply the same way, but what I'm just trying to introduce a different, I guess, a way of understanding it.
Let me, if I can try to summarize,
Yeah.
see if I understand you. There is the Earth here that we're on, and it has normal physics. You get past some certain point, and the normal physics appears to work, but doesn't actually work. It's just making us look like it's working, even though everything works, and we can go to the moon, and we can send probes to other planets and to the moon and deep into space. It's all just a deception of some sort that totally looks like it's real.
Well, and that's, I'm not saying exactly that. What I'm saying is how did we learn as human beings? How did we learn of this? How did we learn how to put a satellite that would stay up there? How did we learn that?
Well, there's Newton's cannon is kind of I think it's Newton's cannon, the idea of how orbits happen, right? You launch a cannonball, and eventually it'll curve down and hit the ground. You launch
it, do it fast enough,
and if there's no resistance to air, it'll
assuming
just keep
that there
falling
is
indefinitely.
Curvature.
So yeah, so all right. So somebody Connell Silverfur asked, said, it could be, therefore it is not an argument. Cite some evidence or stop pushing the delusion, he says. So
he also said we learned by experimentation and observation, right?
Yeah.
So observation is how we learned how we can make things work up there the way that we do, right?
Yeah.
So what if the observations that we make in another kind of place, and what I mean is it's a moving place up there. We could go up there, but we're going to fall right back down. We have to be moving to go up there, right? And this is where maybe if we do a stream on my channel, and we can get more into some of the scripture stuff. But this is something I've learned, believe it or not, out of like what the prophets that wrote the scriptures, they talk about some of these things. Not all of them, but some of them do. And they talk about a place of darkness, like outer darkness, where there'll be weeping and gnashing of teeth, like where Jesus would cast unclean spirits into outer darkness.
I take that as more of a allegory or a metaphor than a physical place. Right? Is that kind of the?
Yeah, I understand.
Not meant. I think it's poetic. It doesn't.
What if? Oh wait, I got a way that. Okay, I should have run this by you before I ask you if you want to talk about it. And I'm sure you'll laugh and you'll be like, oh yeah, let's talk about it. I just have to find. Okay, STS-75. If I say that, do you know what I'm talking about? The shuttle mission.
I don't know anyone in particular.
You will when I show you just this image. I have to just find. I have it here somewhere. They got kind of some strange footage from the shuttle. Do you remember when they had a tether on the shuttle and they were reeling it out? Do you know what I'm talking about, or you don't?
No.
Oh, Sorry, it's taking me so long to find it
Okay.
here. You're gonna laugh, but you'll definitely recognize the image I'm gonna show you.
Jose Reyes is asking you if Asgard is real.
Oh yeah, I've heard of it. Okay, so this right here. Let me just make it bigger so you can. Okay, do you know what? You've seen this before, right?
This isn't ringing a bell.
Okay, 1996.
Okay.
They had. I'll have to get the actual video now. That was just like a GIF image that I made. STS-75. I don't know what the satellite was for, but they had a tether and a boom that went out of the bay of the shuttle, and then they let this satellite that was connected to like a cable or a couple cables or something, and they let it go. I don't know what they were trying to do, but they kept unreeling it out, and it went out like, I don't know how far, like miles, I think. And then it broke. And so there's this mile long tether thing hooked to this satellite. And so as it was drifting, like they're orbiting, and as they're continue to orbit, it's slowing down a little bit, or it had some, movement away, or when it snapped or something. And so they're just tracking it. And sorry, I'm not very good multitasker here. I'll grab the video, and you can hear they don't know what to think of it. I think they're just saying, we see some star-like things and whatever. But let me just go to the. So this is a NASA. They did like I don't know what they called it, video file, flight day 9, and I'll fast forward and kind of show you what. Oops. Okay, so this tether, I guess I might. There's another video that you can get it on, but excuse me. So I'll zoom in a little bit. So this is like the tether, I guess, when it broke off, and they're just tracking it, right, as it's moving away. And of course, they're moving orbital velocity. So it's moving orbital
they're all
velocity.
moving about the same speed relative to each other.
Yep,
Yeah.
Yep. And then it's just inching away, as they're filming. But I'm not going to try to waste a lot of time on it. So then they finally there's something like 70 miles away from it right now. Okay. And can you see my screen okay?
Yeah, it looks like a lot of out of focus stuff.
Yeah, it is. It is. And then they'll zoom in a little bit. Oops, there we go. So I just want to get your thoughts on this, and I can explain what my thoughts are. But so this is I don't have the audio. I don't think you'd be able to hear it anyway. So there isn't much audio, but he says, what are you seeing on the screen? And he said, we're seeing some star-like things, some things floating in the foreground, or swimming in the foreground or something. And so there's these things, and that tether, there's something, that tether's like 9 miles long or something. So it's kind of strange what we're seeing.
It just, stuff is out of focus.
Well, that's what you'd think, but I mean, obviously that it's.
If you don't need to know a lot about photography to see that these of these things are out of focus.
So, we'll just probably move to something else, but I will send you a link to that video so you can look at it on a better screen or something. It is interesting footage, and like those things, they go around it. They're doing it's kind of strange what they're doing.
Yeah. Well, if the tether broke, you'd expect a bunch of crap to fly around. So
yeah.
Debris and stuff out there.
I agree.
So let's do. I have Asylum asked about a map And is there a flat Earth map? He's a
No.
pilot, so he uses maps.
My flat Earth map is when I open my front door. It's no, there's no flat Earth map that works. I mean, I think it's something like
don't you see that as kind of a problem?
No, I don't think. Well, here, let me explain.
People navigate. People get to where they want to go.
Let me explain where the line gets drawn for me. Ask your pilot friend, when he's flying, does he fly in a straight line or does he fly on a heading? Like with the compass, like with the magnetic north. Like I'm just saying,
they fly a heading.
So they don't fly because I don't think you can just get in a plane and fly in a straight line for hours on end. You're going to end up with a squiggly line unless you're flying on a heading, right?
Say that again.
Okay. An airplane. Okay, we could do it with a boat. You could do it with a bicycle, anything. You can try to drive. You can hold the steering wheel straight and you can try to fly as straight as you want, but you can't see much further than however far when you get to that point. I'm just saying you're doing increments. You've seen a boat.
Yeah. And so when a long distance flight is plotted out, they have waypoints all along the route. They'll have they'll get the overview of it, the long range. I want to go from here to here, and then they'll put a bunch of waypoints in the middle. So you aim for a waypoint. You get there, you aim for the next waypoint.
Yeah.
That's how they do it.
Yeah,
but it's all plotted on a sphere.
Yeah.
And the distances are calculated using the Haversine formula, not Pythagorean theorem or the polar distance formula, which would be a two-dimensional one. It's just the Haversine formula, which doesn't work on a flat surface.
What about here's what I say. If you look at the ocean behind me in the screen, it takes a lot of faith to believe you're living on a spinning, on a sphere, I think, from the ground.
But once you start exploring things and testing things and measuring things and having a hypothesis for something and then find out, oh yeah, that doesn't work on a flat surface, right? So you find out, oh, I can't use two-dimensional calculations to find the distance between points. It completely fails. I have to use something else. Haversine works. Okay, well, that tells us a lot.
And you're saying like the Great Circle route or whatever, how they fly it like that. Yeah. That's all plotted because of a sphere, right?
Yeah.
To me, that would I think you could probably do that with any map. I think you could probably make that work. And I know you're gonna say you can.
The distances get wrong real quick as you go.
Like in the south. In the south,
right? It depends. I've seen dozens of attempts at flat Earth maps.
I've never seen one that explains. Now, here's another thing. I'm kind of should be kind of debating with myself here because when I look at like the southern central point of the star rotation or the sky turning
celestial pole.
Yeah. What that confuses me. I know that doesn't make sense on a flat plane.
Can't happen. Yeah.
But again, I'm debating with myself because the flat plane has nothing to do with the sky. Does it? We can make observations.
You absolutely can know lots of things about where we are by triangulating and coordinating things in the sky.
I would agree. We could do it we could do it in the room that you're in or the room that I'm in. We could plot points and we can understand a lot by the sky isn't moving in the room, but
okay. So I have somebody asked Asylum asked, he wanted me to clarify, why is all navigation based on a globe? So
because you live on a globe, so you're going to make sense of it, right? what if you don't
I live
think
on
of
the
things
same
that,
place you live, man.
yeah, I know. And you're what you don't understand. It is how you see, for one, it's how you see things. Like you'll tell me right now that the room you're in is moving at a certain velocity sideways as the earth is spinning, right? And
Yeah.
I'll tell you the room that I'm in sure isn't. It's just sitting here. And so what I'm saying is you could be right or I could be right, right?
It's
There's two ways to look at it, right?
it's one of us or neither.
Exactly. That's true.
To
So that's
be fair,
yep, I
it
agree.
cannot be both of us.
Exactly.
Correct.
And so you say that you have evidence of this because of ring laser gyroscope, or everybody in the chat's going to say thanks, Bob. But you have that, right? But I have the Saturn V behind you.
A lot more than just
No, I know.
Bob.
I know. No, I know.
Yeah.
I'm just kind of being silly, but what I'm saying is I don't look at the sky to be the same type of place that you do, even though
But a ring laser gyroscope doesn't rely on the sky.
it relies on light, right?
Not
And reflection of light.
inside
Yeah.
of it. But that's
Yeah.
not the only way to measure rotation.
Didn't you know, MC Toon? I thought you knew more than you do. Didn't you know that photons don't like turning left? They don't like taking a left turn. So I'm joking.
Which way's left?
I'm just joking.
It's not just light though. There's other ways that we have measured rotation. I have on my website. You have to. I mean, I know you've watched a few of my live streams.
Yeah.
On my website, mctoon.net/spin, I have 15 different measurements of rotation. Just
Okay.
a few of them are optical gyroscopes.
Okay.
There's one that uses liquid helium, which has no viscosity, inside a toroid, and then it has a sensor to measure the flow.
Okay.
So since there's no viscosity, if you turn the toroid, the hydrogen,
it just works very similar to a ring laser gyro, but it's not. It's
physical.
Measuring the time.
It's physical.
Yeah. Okay.
And so it measures that. Now that's not the only one. There's another one
that drifts like what you'd expect. Like, is that what?
Yes. Yeah.
As
because
you turn it,
because it's oriented so that the axis is up. It varies with the cosine of the latitude, cosine or sine.
Oh,
of the
yeah,
latitude.
because you're at a different
So on the North Pole
radius or
on the North
diameter.
Pole it will measure 15 degrees an hour, and at 60 degrees north or south it will measure half of that. And
okay,
so
there's also the weighing things at the North Pole and then at the equator that could be looked at.
The Utbush effect. I'll give you one more.
Okay.
They used a 15 Tesla electromagnet to levitate, or whatever, a hover a plastic sphere, and then they spun the sphere really fast, and then they used lasers like they did in the old mice that had like balls in them.
Mine don't even have a laser.
Yeah,
I don't think.
My
battery's probably dead.
Yeah, but they to measure, it measures the surface movements, and then it measured a same thing, the rotation of the Earth based on the latitude. But this was 3-dimensional, so it was actually measuring a full 15 degrees. All of there's more.
Pendulums.
Pendulum is another one, and I intentionally don't list that one on my site because so many people just
too controversial.
It just because it's like that's gonna be the one that they think I'm gonna cite, so I intentionally don't cite it just to mess you up. Yep. I also rarely mention NASA, and for some reason all the flat earthers are like, you can't know anything without what NASA says. Like I don't need NASA. So
NASA probably gets a lot of things wrong at first, anyway. I'm just saying, like, anybody that's learning something. Well, when they were when von Braun was working on the Saturn V, I'm sure they had failures before they put men in them,
there's
right?
trial and error, absolutely.
That what I'm saying is nobody knows everything. So, but let me comment just on all those that you mentioned. I'm not going to specifically comment on all of them, but because I don't have like a rebuttal. That's not something that I can offer for some of those. But what I'd ask you is, what about in the room you're in right now? Is there, because would you agree that the kind of proof you're talking about is mostly like measurements with some kind of measuring device?
Absolutely, it's a measurement. Yeah.
Physical measurements that you physically measure, like a ring laser gyro. That's probably the best example because there's really nothing but light.
They're super accurate. Yeah.
And that's what we use in jets and like fighter jets and everything. So,
yep.
I think that's a good example. But what I'm saying is that unless you had the knowledge and the technology, you would probably tell me something different, right?
If I was ignorant of it, like I
no,
didn't
not
know?
ignorant of it. Let's just use time. Let's go back in time before we knew some of these things. How would you, like today, in the room you're in, would you have any reason to think that it's rotating, that the Earth is rotating?
No, if this was my only experience, I wouldn't. And I wouldn't know I was moving. Same thing, though, if you're in an airplane with the windows down, you wouldn't know either. So that doesn't, it doesn't go too far. Your analogy kind of falls apart.
We're not in an airplane, though. Red's rhetoric kept trying to do that to me. If I was in a van and there was a potted plant on the side and I was trying to film it, I'd have to move my camera. I'm like, let's keep it simple. I'm talking about it's not something that people like, oh, you're wrong then. That's not what I'm saying. I'm just saying your senses in your body, your perceptions that you inhabit, whatever that
let me jump to there's no part of our anatomy that senses constant speed.
No, I know there wouldn't be, because you'd need a change in the velocity to feel it. But what I'm saying is, just because you can ride on a car or an airplane and walk down the aisle and not notice that you're flying at 600 miles an hour, does that mean anything about if the plane's just sitting still? Like if it's not flying yet, you'd have the same thing. So what I'm saying is, you're jumping to the idea that you're, with all your equipment and your, the knowledge that we have, you can go that, you can trust in that stuff, right?
But we have measurements. We've moved past that in our technology and our understanding. So I'm not going to throw them away just because, right? Okay. And nobody should throw them away just because it doesn't fit with their desired conclusion. You should be open to having your conclusion be contradicted and then accept the new one.
I agree.
Right? This evidence here contradicts. I need to throw away that and embrace this this new thing.
Okay, so that brings up kind of like the star trails. I had that in the screen behind me.
Yep.
I don't right now, but what if the star trails are moving, or the sky's moving, or the firmament, or whatever we want to call it, is moving, and the Earth is not moving, we can look at it the opposite way if we want, right? And it would be the same thing. If we said the sky wasn't moving, then the Earth would have to be moving, right?
Taken in isolation.
Yeah.
You could, if you just take the star movement, you could say the Earth is stationary and the stars are moving, or the Earth is
vice versa
moving and the stars are relatively stationary, or a combination of them. Any of that is then possible in isolation, but then you add in more pieces to it.
Yep, I agree.
And it eliminates possibilities. And that's how a lot of how science happens, is eliminating possibilities. Does this work? No. Does this work? No. Does this work? Okay. We've chucked, we can chuck all these things out, and Okay, the things that are left is our list of possibilities, right? And of course, there's the point about science is it's never done. There's always some other way to look at it and say, maybe it's this, let's go test it, right? But there's things that
there's always learning to do.
But there's things that make sense and there's things that don't. So you don't need to bother exploring. Is it invisible red leprechauns that are causing this to happen? It just doesn't make sense. We're not going to explore that. So
what about evidence though that you look at maybe a different way than I do? Like when I hear, I on my channel, I played some video of that 2013, that meteor that came into Russia and broke a bunch of windows, and it was a loud bang, right?
Yep.
So that's what happens anytime that something comes from that place into the earth, right? Would you agree?
Yeah, it's going faster than the speed of sound. So
yes.
At some point it has to cross that barrier and you get a sonic boom.
Whether it's got a heat shield and it survives or it breaks up and starts disintegrating, it's still going to make those sounds because it's of the speed that it's moving. So the evidence that I have right there tells me that the place above the earth, that we call the sky or we call space, it's moving really fast. Or anything in it is moving really fast, because anything that comes out of it is not just falling straight down. It's got a horizontal velocity.
Relative to us, it's moving fast. It has to.
Yeah. So do you see what I'm saying? Like I'm not trying to get, I know there's lots of evidence and a lot of things that we could talk about, but this is kind of what I'm saying is anything that is up in that place is in free fall around something else. That's very different than the Earth.
I'll allow it.
Okay,
it's not
with some stipulation.
I could be more pedantic, but I'm not gonna. I'll that's fine.
And you know me, Toon. I'm not a technical guy like you. I mean, you got a lot more knowledge on a lot of those things. But as far as I'm just like the hick or whatever that's just has some thoughts, I'm not a good debater or something like that, but I do. That's one of the things why I like your channel is because you're very nice, when it comes to some people that have been on your show aren't very nice. And the way you handle it is pretty impressive, to be honest. It is.
There have been a few.
Yeah. There've been a few recently that are quite interesting.
Yeah. Okay. Let me do this. Because I want to explore something here. Harold says this guy's entire problem is literal religious interpretation and dogma. But he's smart enough to put the pieces together. There you go.
Hey, that was a compliment, right?
Go. Yeah.
I think it was.
And then now we got Seek Truth, Speak Truth. What, you know him? You like him?
I think I know the name.
Big fan?
Big fan.
Used to be a flat earther. He says, go back in time to when we thought the earth could be flat. Like thousands of years ago.
He's telling me to get out of here and go?
No, I don't know what he's meaning by that. All right, here's... You have a thing over the frozen lake that you show. Do you want to pull that up?
Sure. I've got should we do the frozen lake or should we do the further one that's on the not frozen lake?
Do the frozen lake first. Crashes says, please remind him that not all us Hicks think the earth is flat, and please stop making us look bad. So Crashes is a fellow Hick.
I'm a northern Hick or a whatever.
And he's like, don't make us all us Hicks look bad.
We could do this. Right. This is interesting.
That one, that's the one I was thinking about. So explain it, because I saw you talk about it on FDFE, but I'm sure.
Did you have your Google Maps or your Google Earth or whatever open yet?
Yeah, I'll pull up the map. It's Mille Lacs, right?
Yeah, if you go up 47 to Isle, there is a scenic lookout.
There's Isle.
You can't miss it. There's a scenic lookout if you start heading north on 47 in Isle there. The lake's on your left-hand side, and I think about maybe where 47 basically comes into the lake. It's maybe a mile north of that. Do you see that? It's like a parking lot that you can see.
Oh, it sticks out into.
It doesn't really stick out too much, but there's kind of like it's not too far off the main drag. Maybe 2 miles north of town there, whatever.
Of the town of Isle.
Yeah.
Yeah, I don't know. It doesn't matter too much to find the exact
Actually,
spot.
you know what?
I don't
And
think.
I have I can give you all the exact I think it was I think it was almost 30 feet. I think it was like 26 feet or something where I had my camera above the water.
Yeah.
So it's up there a ways. And the house that we're looking at in the image here is 9.5 miles away.
Okay. But we don't know exactly how far above it is above the level of the lake. I mean, right?
It's between 25 and 30 feet.
Yeah. So
30 would be probably higher than it.
But now we've run into a problem already because we don't see the shore on the other side. There's something obstructing it.
Maybe snow on the ground, on the ice.
20 feet of snow. This
No,
is
not
Minnesota,
20 feet.
people. But we don't
20
get that
feet.
much snow.
Wait. What's are you talking about the image that I'm got?
Yeah, I'm
playing
looking
right
at the one right now because that house, we don't see the foundation of the house or the several feet.
There's a road right there. Here, let me grab you. I can get you a car driving on that road so you can see. Whoops.
Well, there's a road along the shore.
Yeah.
And there is also roads on the lake, frozen lake in winter that people drive on. They do drive their pickup trucks on the lake in winter because ice fishing is a religion in Minnesota.
It is a city up there in the winter. It's a city on a lake. It's crazy.
Yeah. And it'll freak you out if you've never been on a lake because you hear constant noises and pings as ice cracks and shifts and moves. It's got
that deep boomy kind of the world's ending sound.
It scares the crap out of you for a while. Okay, so like I said, I don't see the shore between the bottom of the
actually
house
you kind of can, and I can explain that to you. There's some trees between the camera and the house that are on this side of the road.
Yeah.
Those trees, if you had Google Earth open and you went and did the what's it called, Street View, you'd be able to see that those trees are actually growing right out of the water.
Oh, they're in
like
the water.
Yeah, like the bank. Okay. I don't know if it's 6 feet or something.
Let's do this. For this conversation, let's grant that we can see all the way to the shore in front of the house.
Can I if we're looking for an observation where we would see something significant, there's not really much that's like, I don't think there should be anything hidden in 9.5 miles when you're 25 feet high. I think maybe 5 feet, if anything.
Okay.
So I do have one in the boat landing just north of here where I've had my camera down 20 inches above the water. And I also did it with the camera touching the water. And I have a video that I can play in the background here to show you this, because this one's looking, I think 14 miles away or so. And with the camera at 20 inches. And I'm not the math guy, but I did the curvature calculator and I know it doesn't figure in refraction. I'm not trying to be like, this proves this. But what I'm trying to say is that at 20 inches above the water, there at some point your line of sight should be tangent and then go below the curvature, and it's only like 2 miles or something, and we're looking 14 miles. Let me get that video here. So this one, I do show a map on here. I can pause that right there. So the right side is where we're viewing from, and that's the boat landing in just north of that that sightseeing place that we were just looking at. But so there's a boat landing there, and I went down, and my camera's 20 inches above the water.
Yeah.
So I'll just let it play here. But so this one, when the water's calm, this is one thing I noticed about Mille Lacs. When it's windy, you can't see the other side.
Yep.
When it's calm, you can see all the way across to the other side. And if you look in this, you'll even see houses, which are like 12 miles away. And my camera is, or 13.4 is where that spherical water tower is. But those trees right there on the other side, I think those should even be behind that
with
hump of water.
Yeah, with no refraction.
Yeah,
Right.
yeah, with no refraction. But what about what would the horizon be like if we should define that so I understand what you think what the horizon is? That would actually be water in the way, right? I mean, if you were going to see past it.
Yeah, since the bulk of the distance is the lake, that's going to be what is in the way. So,
and then, beyond that horizon would be where you couldn't really see the surface of the water anymore. Beyond that horizon. Okay.
Yeah.
So,
all right,
and I know this video isn't very high quality, but here's I can see these houses.
Yep.
And my camera's 20 inches off the water.
Yeah.
So,
now go back, just pop back to the video just for a second so we can and play it.
Yep, sorry. I don't think I had any sound. I don't think the sound would work, but I put the numbers in.
Yeah. All right, so let's see.
Okay, here's
it's your camera's moving a bit. So I was just checking if it's kind of wavering. Yeah, it's wavering a little bit. So,
and it's not a very good video. It's been copied a bunch.
All right, I'm gonna share something to you.
Okay.
And so here's the deal. You're wondering what should you see on the Earth? What's the right, distance to the horizon? How much should be hidden? All that. So let me show you. These things can be for non-complex things when the temperatures aren't crazy. We can calculate them well. When they get more complex, it's hard to model them, and typically you just say, I don't know, it's too crazy. So here is Andrew Young at the University of San Diego models all this. He's a PhD instructor there. He's written a few papers and stuff. This is his website at South Dakota State, or South Dakota, SDSU, which is San Diego, not South Dakota State University. So here's an example. You see this curved surface here, which is level, defined as level. And then a line of sight there is that dashed line going down. That is no refraction. And then he has the math for that. And then if you actually look at here, you can see this 1.23 miles times the square root of the eye height in feet. That is what QE uses in his Black Swan junk. And then he stops reading. You see this next section here says refraction considered simply. There's a whole lot more. I'll scroll down. There's a lot more to this write-up here than what this small amount at the top that QE looks at and then assumes there is no refraction. There is refraction. There's no way around it. If there is a temperature difference, it's going to cause refraction. When there's no wind, a slight wind can tend to actually mix the air so that there is less variation because it gets all mixed up, and so then it's more consistent. Anyway, so he talks about and has this thicker line. You have the dashed line underneath the thick line there. You see that?
That'd be your line of sight.
Yeah. So the dashed line is the former straight line. And then the the thick line going from O to H, right? You can see a little farther than to G. That is a curved line of sight due to refraction.
Okay. It goes down like that, kind of.
It curves down, but the light has actually, because it curves down, it appears higher. So if you put yourself at the position of O, the observer,
Yep.
you're gonna look up a little bit more, so it's gonna appear higher than if there was no refraction.
So the 12 miles past that horizon that we see the water for, that would be because of refraction. 12 miles.
Now here's the key thing. That curved line of sight due to refraction can be equal to the curve of the surface of the Earth. And if it is, then there's no limit to how far you could see. It's never consistent, right? There's always lots of variations. But I don't think he has he doesn't draw a picture. But if you can, in your head, imagine that curve from O to H, if that curve was equal to the radius of the Earth, there's no limit to how far you can see. So when people say, I see people
technically see your own butt.
Now,
if you could see that far,
there's obviously other things going on. There's not consistent gradients. There's over a lake, it's different than over land. There tends to be a lot more over lakes. So
basically, if I'm getting you right, you're saying that if you're seeing anything farther than what the curvature, the math would get us as far as without refraction, it's all refraction. And so this is kind of where the argument or the debate kind of gets.
It's possible. I'll grant that
that's what you're saying.
If the conditions are not favorable to refraction like this, and you still see too far, then hey, there's an issue. Now we can measure this. There's a way to measure this. It's called the lapse rate. That's the change in temperature, the vertical change in temperature over distance.
You schooled me on that before.
Yeah, I think
on the lapse rate.
Yeah. So if you have 1 degree change Celsius over 10 meters, that is right about the necessary gradient to have the curve match the curve of the Earth.
So it kind of makes the debate, what I'm getting at is it kind of makes the debate hard to have, and it becomes more of like belief.
What it does is it makes these particular observations very, very difficult to draw conclusions on.
Yes.
That's the problem. And so I don't like to look at here. I'm going to stop.
I'll grant you that. But I will say this on the opposite side of that is that if we look across a lake that looks flat and we see the other side, there's a way to look at it without considering the refraction and what I'm saying is I can see the house on the other side of the lake. That's enough for me. You know what I'm saying? If we look at the math and it's so drastically different. What I have, I'll keep playing this in the background, but this is GitHub, one of their curvature calculator or whatever.
This particular one doesn't have any
it's just Pythagorean theorem, I think.
No, this one, I do think this one is using the proper trigonometric formula.
Okay. But if we go up, it's showing a horizon distance of 1.61 miles.
Yep.
And I guess the target hidden height is not as important to me because that's really hard to know what you would see, I think, from something being hidden, because really what's in question is this horizon, whether the light's bending around the curve or whatever you're talking about. But what I'm saying is if simply geometrically, if we have a circle and from the center of that circle, we go up to my camera height, that's just 1.75. So what is that? I haven't thought about it for a long time, but what is the radius of the Earth? Is it like 3,900 or something?
About 4,000 miles.
about 4,000. So you'd have 4,002 feet to the camera, right?
Yeah.
I'm just saying there's simple geometry that we can do to get a general idea of. And what I'm saying is that
here's the deal.
okay,
This absolutely requires that refraction is not happening.
no, if you're going to say that those numbers, but what I'm saying is we have to. I do think refraction happens. You can see it happening. You know what I'm saying? But you can see light bending all the time through different mediums and everything. But what I'm saying is that 1.61 miles there should be a horizon there. And then, so let's say with the refraction and everything, what would you say that should go up to if it's, favorable for a curve or whatever?
Indefinite. If there is
indefinite.
If there
so
is,
there wouldn't be a horizon.
It would be blurry. But the thing is, it's like I said earlier, it's never consistent. There isn't a indefinite distance of the same.
Yeah, it's different
gradient, right?
You're looking 20 miles. You're looking through different weather systems.
Yeah, and then you get to land, and then the refraction is much less. So there are conditions that are much more favorable to heavy refraction. If there's no sun during the day, later in the day, then and into evening, you get very high refractive. It's called the coefficient of refraction. And
I think if it's say early in the morning and in the summer, it's cool out and the water's
not
cold.
Just that it's cool. Yeah. It's that the change in temperature.
Yeah.
Is
it'd be,
very
that's what I'm
small.
saying is you'd probably have a clearer view in the morning than you would when the sun came up and it got the air warm and once it's warmer.
So when we want to measure whether or not the Earth is a sphere or flat, using these particular measurements that are very susceptible to variations based on refraction, let's not use them. I don't like using them. We can, right? Reciprocal zenith angles are slam dunk. Yep. But to be more precise, you need to control the conflating variables, and that is a difficult one to control. And
it's almost impossible.
When you move farther closer to the ground, it messes everything up even more. It doesn't make it better. It intentionally introduces more variations, and it reduces your ability to draw a useful conclusion. All right, I got a few super chats. I want to go. I don't want to get too far behind.
I'll play some footage of the lake with fish houses on it, just so people can see in the background here, so people can see how many fish houses there are on that lake.
This is a good question. From Team Skeptic, he's asking, which is more dense, humid air or dry air, and why?
I would say that humid air is, because it has more water in it. I don't know.
This is
probably a trick question.
It's not meant to be a trick question, but
dense. I don't know.
All this only requires about middle school science, right? So
you're probably not going to be able to help me out then. I'm just kidding.
The periodic table. All you need to know is that every element has a weight, right? Nitrogen is 16. 12. Wait a second. People help me out. Going from memory. I'll look it up so I don't get it wrong. So the atmosphere is 78%. All right. I wrote it down. I'll pull it up. I don't want to just be guessing. Okay. Did I write it down? Dang. I don't have it. All right. People help me out. I can get the periodic table.
I could Google it for you.
No, I got it.
I'm just teasing.
All right. It's mostly nitrogen and oxygen, right? So you got nitrogen comes as N2. Nitrogen's molecular mass is 14. Oxygen's molecular mass is 16. There we go. Hydrogen's molecular mass is 1.
Team Skeptic's just having to do his homework.
There we go.
His
Yeah, I
kid's
know.
homework. No, I'm just
Team
kidding.
Skeptic. Write this down, team, and you can use it in a video. Nitrogen comes as N2, so it's 14 times 2. We have 28 is the molecular mass. Oxygen is 16. There it comes as O2. The molecular mass is 32. 32. And we've got then H2O. Right? 2 hydrogens, which is mass 2, and 1 oxygen, which is mass 16, giving us a mass of 18. So if we look here, right here, we've got nitrogen 28, oxygen 32, and water 16. Water 18. Yeah, you're right.
Yeah.
Water has a lower molecular mass than the other. So if you
I was wrong.
Yeah. So if you
it
displace,
was opposite of what it.
Yeah. So
actually quite drastically wrong a little bit.
And
yeah.
It's common. And until you just think about it, there you go.
And that's something that I'm not going to try to act like I know things that I don't know, or that I'm familiar with things that I'm just not.
So it also has the opposite effect on refraction than what most people think. Now, in the winter, the air is very dry. There's very little of water vapor in the air. So
it's a good time to look at the moon. I know that.
Oh yeah. But in the winter over ice, if you've been ice fishing, what gets cold quick? Your feet. Yeah. Because on the surface of the ice is significantly colder than up at head level, right? The lapse rate from your feet to your head
changes drastically.
Is enough to refract light at least or more than the radius of the Earth. So over a frozen lake, you can see indefinitely far.
I would agree. It's really crisp video looking in the winter.
Okay, so let me get back to this. All right. We got Asylum says, once you drop faith, you'll be back to the globe soon. But I gotta say, 2 billion Christians, they don't think the Earth is flat. So
what's that?
Not 2 billion? About 2 billion Christians in the world. And
I was reading Holy Small's horrible. I don't get it. Their super
comment?
chat. I don't know if you got to it yet.
I'm not. That's from Asylum. All right. So there you go. I think that. See, I think that you're coming from a position of it's flat because of faith, and then that overrides other things. But all right, let's keep moving though. EftupWorld, on the globe model, what causes the celestial poles?
The Earth rotating. That's
excellent.
There's a top and a bottom. The problem I have with that is I don't think people live upside down for me.
There isn't a top and bottom, and orientation is.
But here, if that's one of the things that I think we're being careless with. If
Can anybody hear me? Let me know if you're hearing me. I turned off the fan again. not do that. Gotta pull up, there we go. How do I join the existing meeting? There we go. Do you guys hear me? Yes. All right. Good. You want me to beatbox? No, you don't. You don't actually want me to beatbox. How do I join the existing meeting? There we go.
Computer froze.
There we go. All right.
He's back. All right.
I got you back. Nobody was hearing it. You
I was just
in
confusion there, going, I think something's wrong.
All right. Yeah, I have I have the computer gets hot, and so I have to have a fan on.
You had that happen, I think, one of your other streams not long ago.
And I forget because I just have a little fan above it, and it blows on it, and so it's cooling down now. So, all right.
I forgot to show you. I got I got something to show you, but you go ahead. All
right. I forgot my train of thought now.
Oh, I screwed you up, huh?
Well, it wasn't you. It was the computer freezing. Were we? Oh yeah, talking about the celestial poles.
Oh yeah, we were talking about those. Or that was a question someone asked. What causes the southern? What is that? The
southern
polar,
celestial pole.
Yeah, the celestial pole.
Yep. Well, at least you understand it on the globe.
Yeah.
So, all right, let's see.
Here, I got Simon Dan on here for a minute.
Yeah, he did a video earlier today. Simon Dan was on it. Fight the Flat Earth was on it. You even had Bill.
He was. Yeah.
You even had Bill Nye, but not me.
I just didn't get around to taking a picture or going and downloading a picture of you.
If you're gonna have anybody, you gotta, right? We're both from Minnesota. You can't leave me out.
You know, I play with the graphics in a very amateur way. Do things like this, just little images that I make. They're fun.
Yeah.
So here's one. This is a good one. This one might get the conversation might be a conversation for my channel. Who knows?
Abominations and detestable things.
Ezekiel saw them.
Oh, I know you're talking about that before. All right.
I'm just saying we'll talk about that at another time, I think. But
yeah. All right. Let me catch up on super chats, and then we'll get back because I have another thing I want to talk about. All right, so Cretan Ball says, I'm happy. Oh, sorry. Micro Raptor has a super sticker that has coffee. Somebody drinking coffee. Thank you very much, Micro Raptor. Cretan Ball says, for 5 Canadian, I'm happy to be saying this in back-to-back weeks. There's hope for this guy. You got another fan there.
All right.
Peachy Tony, what about all the seismic evidence for the shape of the Earth? Now, I don't know if you've heard
seismic evidence.
PhD Tony before.
I've heard people talk about him.
So, there are monitors all over the Earth. So when an earthquake happens, people receive data that it measures the movement, and based on what time it happened, you 3 or 4 or 5 different stations get it, and they know what time they can know the epicenter of where it happened.
Yep.
Then other places on the Earth also get it later, including getting it on the other side of the globe,
The upside down side.
almost, well, there's no orientation, so down
I'm
is
teasing.
towards the center.
Yep. To you.
Well, in the model, right?
Okay, in the model. In the model.
You have to, right? And
I'm just teasing.
that's the way. Yeah, you can't discuss the model and then say no, right? And you're not, and I appreciate that. So, oh, Microraptor really likes you. He says this guy seems really nice. So on the seismic data or movements is measured on distant parts of the Earth, and the amount of time that it takes matches a globe and doesn't match at all any particular flat shape possible.
Well, there's a lot of things that get said like that, though. Like Red saying an equatorial mount doesn't work on a flat surface because you only have one side wheel motor, when in the north it works just fine with one motor.
No,
but
it actually doesn't.
So how do I track things then?
Because you're on a globe. So here's the deal.
Well, no.
Here's the challenge.
Let's talk about that. Let's talk about that really quick. Just if you don't mind. I don't want to steer away from where you were going.
Well, yeah. All right. Let's talk about it. So go to here's the deal. Go to Valley Fair. They have that ride that you sit on that's got all the swings on a chain.
Yep.
Right. And then it goes in circles and it lifts up a little bit, right? Mm-hmm. If you could get underneath there, now they won't let you get underneath there for some safety crap or something. But if you're
he's going to lose his head,
if you get underneath there and then pick a point up on the, not one of the swings because they move around, but pick a point on the top of the thing near the center, because it'll be a little bit easier. And then set up an equatorial mount that only has 1 degree of motion, one axis.
Or you mean one axis?
It's going in an ellipse, right? That point is traveling in an ellipse. You can't track an ellipse with only one axis of motion. It doesn't work.
I don't know what happened to my Zoom thing.
I still see you.
Well, as long as it's still working, I don't need to see me. I got my laptop over here. I can see what's going on too. Would we be able to say that? And I'm not trying to be exact. I know the Polaris moves a little bit, but in general, is there a circle that the stars appear to be doing around Polaris as it goes out? Is that a circle, or is that a different shape than a circle?
Well, the only place that it's a circle is if you are at the North Pole. Everything else is going to appear to be an ellipse.
Let me find a video to hopefully kind of show you what I'm talking about.
Skydiver Tanner is another Minnesotan. He says the power tower drop at Valley Fair proves gravity.
Oh, nice.
Actually, they launch you down. It's a really tall thing. You go up. There's two. One where you sit on the ground and it launches you up, and then there's another one where it lifts you up slowly to the top. And then it actually launches you down. You actually go down faster than gravity does. And
it shoots you downwards.
Yeah, so your shoulders go up against the harness because you're.
Oh wow, that's scary.
There's one. You've never been there. You live here.
I haven't been to Valley Fair since.
Oh my gosh.
Probably 25 years ago. I don't know. It's been a long time.
There's one old one in Chicago at Six Flags that is not. It doesn't shoot you down. It's actually just a free fall. And that one is a weirder feeling that just drops you. So
the image that I have on my screen, if you can see it, it's not very good, but that's just the North Star and a couple hours of the stars turning or moving or whatever. So people can say that's because we're spinning on a globe. That's not really what I'm talking about. What I'm talking about is, are those stars doing a circle pattern or a different shape of pattern? as from the ground.
I think that's an ellipse, and the farther south you go, the more elliptical it is. I'm not
And
certain. I
how
could be wrong on.
I think because I can't say that I've
No,
tried this south.
I'm sorry. I think I am wrong on that. It is.
I only know
Yeah.
this. I only know this, that if you have, we could do it with if with a record player, like an old record player, if we flipped it upside down and put it on the ceiling, I could use an equatorial mount to track that anywhere on that if I point my axis of rotation at the center of the rotation of the, do you know what I'm saying?
You could track the center, but I don't think you could track one star. That's it. Give that a try. I'd love to see that happen.
Oh, I do all the time. I have footage on my channel. Like I have a half hour of it just tracking the moon, and I I didn't even touch it.
Oh, there
and
we go.
Just...
Okay. I was mixed up. Cinnamon Control says it's always circles, but would be elliptical on a flat Earth, and I was missing on that.
But I don't think it says anything about the surface necessarily. We're talking about what appears to be happening in the sky, and I know it's a circle because
there are geometric consequences to being on a flat surface with a sky like a plate rotating, and a geometrical consequence to being on a sphere and having very distant stars, right? That there's only one that I've ever been able to not understand, and I'm just being honest, and that is how, if you look at the image behind me, I'm looking to the north and I'm at 45 degrees. Is this your own?
Yeah, okay. This is just from my backyard. So my camera's kind of pointed up at Polaris, and I do the same exact thing with my equatorial mount. I point the base of it, the rotation axis of it, point that at Polaris, and it'll follow anything in the sky that I pointed at. From here. Now I can't say that because Red's Rhetoric was saying that you couldn't do that in Florida. And I know you can do it in Georgia because Nathan Thompson and Whitsitt, they just went to those Georgia Guidestones and did it through that.
Well, yeah, that's the center of rotation is at the same place.
Is the center of rotation. And that's what I'm saying. Yeah. So that's why you only need
not the center. Don't track the center, track something out from the center.
No, I like the image that we're looking at behind me right now.
Yeah.
The camera doesn't move at all. But if I was using my mount, it would just do a still image. It would just do a still image of the stars moving.
Yeah. So somebody had a good idea here. Get a ceiling fan, and a ceiling fan isn't quite big enough. So get cardboard and put cardboard on the ceiling fan, and then maybe a little LED light or something, or a glow in the dark sticker on that, and then set up your EQ mount telescope in there, point it at the center of rotation, and then change just one axis to track.
I built an equatorial mount that only has one motor hooked up.
Okay.
And I track things anywhere in the sky by pointing it at Polaris.
Yeah, on the spherical Earth that we're on. But do it in...
No, just in reality. It says nothing...
Do it in...
In the south, that's where it would give me a problem, right? Is that what you're saying?
No, I'm saying test a known flat rotating dome. Do it in your house with the ceiling fan.
Well, who says it's a flat rotating dome, It's the stars in the sky.
Almost every flat earther I've ever talked to, but yeah, you're definitely an outlier.
It is what it is, though. I mean, if it's stars that are 1 billion light years away, or if it's stars that are 33 feet in the sky, if this is the image that behind me if this is the image that we're getting from the ground, I'm just saying the ground, my telescope, I can assure you, to get this image. Or, I mean, this was a Nikon P1000, so it just sat there, one spot. And so the stars were moving around in a circle, which, again, I'll give it to you. If we were on a globe, they would appear to do that. But where I run into a problem understanding is when you go when you go down to the south, like if I want to keep that polar center to the north, like my orientation of the base of my scope, the equatorial mount, I can only do that till like Mexico or whatever, like to the equator, and then Polaris is not visible anymore.
And that's another problem for.
No, it's not, and it's too far away. Do you get what I'm saying? It's
I know what the claim is, but the thing is, that
it appears to do that as you.
yeah,
Like, I drove
on the surface of a flat area. It would be the arc tangent of the distance, the elevation of the celestial pole divided by the distance from the sub celestial pole point, the geographic pole. That would be the elevation above the ground on a flat surface, but that's not what we see.
Well, but I think that's where my understanding seems to be different. Is I don't think of the sky as being the same as the Earth, like seeing things even. Like when I know Astronomy Live, is that, I think that's what it was. He measured, Reds was telling me how they measured the distance to the sun by using Mars and getting the parallax measurement from 2 spots, and then taking that angle, doing the math, and getting the size of Mars. And then they use that, I can't remember exactly, but they use that to get the distance to the sun, right?
Yep.
I'm sure that's great. I'm not saying that there's anything that I think that's a legit thing that they're doing, but
then
I don't think that the sky is like that.
Does it really matter if you? I don't think, right? It doesn't really.
Let me give you an example. I was trying to point out how the sky or space, I'll say, how everything's different in space than it is here on the Earth. Like if you go into space, you have to be moving very fast.
All right, we already went over that. Let me. I want to go.
Well, there's more.
Catch up again on Super Chats, and then I want to show you a technique to measure the if the Earth is spherical or not. That doesn't have you look up at the stars, and isn't modified by refraction, isn't screwed up by reflection. So we've got all right. Adrenochrome Slurper.
What? What a name.
He or she is picking on the cucumbers. Says, what's the best evidence for flat Earth? Just give me one thing quick. What do you think is the best? The flat Earth is the best evidence. All right.
That is my best evidence. That I live on it. And I observe it every day.
You see it's a little circular. That's fine.
It is circular like the stars behind me.
Yeah, the argument is circular. All right. I'm going to show you this picture here.
How am I going to see it? I got to figure out my...
well, I'll have it on the stream, so you'll see it in a second here in the stream.
I think Zoom moved me to a different page or something.
Yeah, you might have. I don't know. Sometimes
I think I lost Zoom somehow.
It's still there.
I can watch on here, though. I can watch on my laptop.
This is a photograph taken on wet film on Apollo 8.
Okay.
It's called You see
it?
Oh,
okay. I can see it. I can see it. Okay.
It's called Earthrise.
Earthrise, yep.
So you don't disagree that people went there. You don't argue
I think there's a real picture.
Okay, how can that be a real picture and the Earth be flat?
Because I think now this gets really. I'm not going to try to explain what scriptures and everything, because I know that that's really not the format here. But that is what gives me the understanding that I have, that you can look from that place of darkness, and if you look at the Earth, you're not seeing a true representation of what the Earth is.
Okay, so
because I think it. I'm just kidding. I just read that in the chat.
So
No, it's just
goes
what the
back
prophets were writing
it
about.
goes back to you pre-selected a conclusion and then you're just going to shoehorn everything into it, right?
Well, it comes from it comes from from me learning a different conclusion, not from science
picking a conclusion ahead of time.
or believing a conclusion. What I'm saying is, I don't believe that the Earth is a sphere. I don't believe that. So, what I would call
it's just
I'd call you believing it.
So okay,
that's what I'd say. You believe it, right? With great evidence.
I don't.
Right?
Yeah, it's based on evidence. It's based on evidence, not
and you
faith.
believe that evidence. That's what I'm trying to say. It is I'm not trying to rip on anybody or trying to like say anything really too outrageous. I'm just saying that everything that we understand, there would not be a debate if it was a belief or if it wasn't a belief. It's obviously a belief because there's some people that believe this way. And some
just because some people disagree with the facts doesn't make the fact not be a fact.
Well, but right. you're calling certain things facts that I don't consider to be,
it's just denial though. All right, let's.
I could tell you that the sky turns over on top of the Earth all the time, and for some reason you're gonna disagree with that, aren't you?
But if you have evidence to support that, I'll.
Well, it's right behind me on the screen. Yeah. I'm just saying, my camera didn't move, so.
Right? All right, we have it's Russian ATAKZE. I don't know. I can't say. Says from Apollo's landing spot, Earth is straight up. You're correct. That photo I just showed was not taken from the surface. It was
they were orbiting, weren't they?
That was taken from orbit around the moon, and
as they came up over.
So, Mr. Russian flat earther, do some research, please. All right.
Even I knew that.
Yeah, exactly. All right. Holy Small says by the way, the bottom of his water tower is 1,289 feet above sea level, and no matter where he is on the other shore, he's looking up.
I think you got to realize that the other shore is also at 1,200 whatever.
The challenge is that's not the ocean, that's a lake, and so the math is
lake is 1,256 or something like that.
It's a tiny bit different.
1,254 or something.
So all right, rodent,
so that's 30 feet.
Rodent, no last name, says MC Toon. I thought Daft Punk broke up.
Daft Punk?
Too soon, man. Too soon.
So see, when here's the point.
We're gonna have a moment of silence for Daft Punk. I like Daft Punk. Yes. So it was yesterday or today I saw that Daft Punk broke up. Daft Punk is a techno kind of band from France. From France, right?
I have no idea. I don't remember.
They did the soundtrack to Tron.
Yeah.
I have my tune is just I turn the R to an O, and this is from Tron. So yes, I do love Daft Punk.
I was thinking about making you like a intro or something sometime with Tron stuff, but then I saw you already have one.
I already have one. Yes, thanks. I saw a Daft Punk cover band at Mill City Nights several years ago.
Mill City Nights, where's that?
That's in Minneapolis. It's closed now, but it is.
Hey, I think I went to. No, I'm thinking of the Mirage. I think.
Yeah,
I went to a King's X concert one time, and I think it was at the Mirage.
Yeah, so Mill City Nights used to be Club 3 Degrees, which used to be the New Union, which I know you've been to. We can talk about that maybe a different time. But anyway, I gotta keep moving here.
Yep.
Connell Silverfur says, "Effed up, you're essentially admitting that you're willing to believe a lie. How can you claim to be a Christian yet willingly believe a lie?"
I don't think I believe a lie. I believe what I believe to be the truth.
But if we went to the moon, but the Earth is flat, then we didn't travel. I don't think
they went where they think they went. They have evidence of everything. They went there. They went to the moon. They got pictures of it and everything.
Sounds like you believe in a lie.
No, I believe that there's great deception, and I don't mean like deception like what Nathan Thompson would tell you. There's a bunch of NASA people lying to you. That's just unrealistic to me. There, I don't think that there's people anywhere in the world that are going to their job and lying all day and being able to pull off some great conspiracy that would be not possible anyway.
I don't know
But
which is more. I appreciate your position, but I don't know which is more kind of hard to believe because to say that people in NASA aren't in on it and they're just like compartmentalized.
no,
If you
they're
think,
doing what.
but no,
Nobody.
with the more common flat earther claim, right?
Okay, I'm sorry.
Because either 400,000 people are in on it, or they say, oh, it's compartmentalized. A very few people are in on it. Everybody else is tricked. But if somebody spends 10 years designing a satellite, and then that satellite goes to space, and then they interact with the satellite that they themselves
they're
designed.
using it for signals and they're getting information from
send
it.
Signals, it comes back. If that didn't actually go to space, then there has to be somebody
faking all. It's impossible.
Them, generating the faked information for them. How is that? It takes more people, right? And
ridiculous.
Take a person who spent 10 years doing this. You need to have somebody that knows a whole lot about it in order to generate the faked information.
Look it on my screen really quick. I know it's not super good footage or something, but this is footage that I took of the space station that you can do almost any day.
Yeah.
This is just with a P1000. I could do better with my telescope if I actually tried. But you can clearly see it, right?
Yeah.
And this is a horrible video. My program only runs 1080 and it's really grainy 1080. The point I'm making is that to look up in the sky and to see that fly over, and then to see all those Starlink satellites fly over, we've reached a different type of denial. If a person, since 2019, since they started putting those Starlink satellites up, you can see those anytime you go outside. Now, at certain, the light's not always going to be hitting them, but like I have a night vision scope, you can see them with that anytime you want. You go outside, point it up at the sky, wait till you see one flying, and then just make a note of where that one passed, and you're going to see 60 more, depending on how far you are and how far spread apart they are. What I'm getting at is to deny the things that are happening in the sky. It's at a new level since 2019. Yeah. And so when I'm looking at something like the space station, I don't think there's a single person involved in that's deceiving another person. Everybody that's involved in that is just like everybody in the chat, and just like Toon and me. We have our life and we have needs, and so we go to a job, we try to make money. That's the whole idea that we do this for. And so some people, they go to do their job and their career doing aerospace, and it's a real thing. And it is kind of weird for me to be a flat earther and to see all these. I mean,
do other flat earthers give you crap for that? Because
oh yeah, but here's the thing. It's like Nathan. I told him to tune in on this, but I doubt he will. But if he does, he knows that I'm saying these things, and he goes, "You lost me, bro." He totally disagrees with me, but we're still good friends. But like, we've never had a real conversation about it because he just says, "Ah, it's fake. They're faking it," and that's
just a hand wave dismissal. Just
yeah, and I do possibly have an explanation why that, because that's not just Nathan. That's
most
thousands of people.
That's most.
Yeah, I mean, how many flat earthers do you think there are? There's a lot.
A couple thousand, yeah.
I think there's probably more than a couple thousand.
As far as I know, there are 2 flat earthers that think that we went to the moon. You and Allie B. Do you know of any others?
And to be, to represent my belief there correctly, you also have to add to that here's the way I say it. I believe that they believe they went to the moon. All the evidence that they would need to to convince anyone that they went to the moon. They have that evidence. They did these things. But what I'm saying is that that's what they are believing, but
Yeah.
they're believing a lie.
And your evidence for this is just more faith.
A lot of it's faith.
Yeah. Okay.
I'm not afraid to admit it. A lot of it's faith, but there's very specific reason. You know what? We could go over. We got to have you on my channel, but because then we'll maybe talk about some more of that stuff.
So people, I will be on his channel here. I don't know. We're gonna figure it out. I'll be sure
maybe
to
later this week or next week earlier.
I got a good super chat from People of Earth. Says it doesn't matter if the Earth is flat or a globe, just as long as we can all agree that the dinosaurs built the pyramids. So yes, we definitely all agree with that.
Which pyramids?
The dinosaurs built all the pyramids.
Oh, I don't know. The Sphinx. I don't know.
Isn't
I'm just kidding.
But it definitely was not the T-Rexes. They can't get to the.
It was the Triceratops.
Yeah.
They. That's what it is. You ever been to Dinosaur Adventureland?
No, I don't know what that is.
Oh, okay. Most of your people in your chat probably do.
I was never super interested in dinosaurs. My cousin who's younger than me, he loved dinosaurs. He loved Jurassic Park. And like when he was young and I was in high school and I'd see him and he's like, "You want to play with dinosaurs?" No.
Yeah.
Not interested.
Yeah, I wasn't too big into the dinosaurs. I was more into like Transformers and stuff.
He writes software like I do now.
Oh, okay.
Pretty cool. The Microraptors carried the small rocks.
What was that?
Microraptor said the Microraptors carry the small rocks. Okay, I have. Let's see. There are ways to measure without looking at the sky.
Okay.
The shape of the Earth.
And know the radius. I'm sure you'll convince me too, huh?
Well, yeah. I mean, you're just gonna say I have faith that it's not true, and no evidence.
Well, no, because I already showed you video of looking across Mille Lacs Lake from 20 inches above the water, and if we're gonna look that far, if there's curvature
and no refraction,
no, add refraction in there. I never got an answer from you.
What?
If a horizon, you said it could be it could go around the curvature. What I'm saying is, when I'm looking across the lake, you're saying that the things that I'm looking at are like 100 feet or whatever lower than they actually are, or higher.
Yeah.
Yeah. And that's what I'm disagreeing with. I'm just looking at them right over there. So that is, for me to believe in some curvature measurements that somebody got their whatever the tools they use for surveying or whatever it is, it just isn't going to convince me when I can just look across the lake and go, "Oh, there, look at that house over there." And there's no water on the lake being blocked by anything.
In science, you don't just take one thing and then draw a conclusion, right? You build a collection of evidence.
But I think reputable evidence that has veracity needs to be there. And if we're talking about we already kind of came to that with the refraction, you're basically saying the refraction, you'll never see whatever you're looking at. You're just looking at the curvature of the Earth. That's what you're going to say. And I'm just saying my eyes argue with that.
So that's why. All right. So that's why I'm going to show you this one here. So without looking at the sky and using measurements that aren't heavily messed up by vertical gradients, you can do left to right looking with theodolites. Okay. So
that is something else that we could talk about. That I don't know if you got a chance to watch that video, that I just premiered before we got on here.
I was there. But
let's not internet went down.
Yeah, let's not go into that because
that's a long topic.
Okay. So I know you were asked before, you better get this right. If you have a triangle sides 1, 1, and 1, what are the internal angles?
1, 1, and 1. I'm just kidding. You'd need 180 degrees, right?
Yeah.
So you'd have 60, 60, and 60,
Yep,
right?
that's right. All right. So I have here, you'll have to look at the stream. I have it's different on the surface of a sphere. A spherical triangle has more than 180 degrees and less than 540 degrees.
And are you just saying, how are you traveling over that to measure that with like a measuring line, or like an airplane or a car?
You measure with a
Or
theodolite.
just concept?
With a theodolite.
Oh, okay.
Yeah. So go to, and then it's typically done from high points, where they'll build a structure. So they'll measure.
How do you get your? I'm sorry if I'm interrupting. How do you get your angles accurately marked, and then the heading? Because you do this on a large scale, right?
Yep.
So your heading, is that you're going to use a compass for that heading?
No, you would use if you need
is it by sight?
If you need a heading, you can use the center of rotation in the north or south. So this
so you have to do the triangle around the center of rotation.
No. None of this requires a heading. You don't need to know a heading. All you're
saying like a concept. You're saying a concept.
No, this is an actual empirical measurement. Just let me explain it before you.
Sorry.
So go to the peak of a mountain. Have two people on other mountains or structures that are high. They tend to do this at night, because what they'll do is they'll have a light, or they'll build a fire there, right? These older ones, they'd have a fire, and then they'd have mirrors to focus it. And then what you do is you measure the angle between them, right? So you do that, and they would do it multiple nights in a row. They'd measure back and forth, back and forth, back and forth, and get lots and lots of measurements over time.
So we're talking like 20, 30, 40 miles distance between the points, or anywhere in there, like larger distances. Okay.
Many miles of distance. They do these in these large surveys, and they get these triangles, and they measure these triangles, and they, if we're on a two-dimensional surface, the sum of the internal angles must be 180 degrees. If we're on a non-flat surface, then the angles are going to be more than 180 degrees. Right? That's just how it works on the surface of an object that is not flat. On the surface of a sphere, there's a whole lot of then math that comes into play, using the law of cosines and things like that. So in the chat we have Dr. Clive Wells, who did a fantastic job here presenting a mathematical proof of this particular formula right down here at the bottom. Cosine of C over R equals cosine C plus cosine A times cosine B, all over sine A, sine B. Right? I'm not going to go into the proof of that. It's pretty involved. And I'm sure you're not too interested in that either at this point. So you can measure these triangles. You get them. It's part of these long distance surveys, and they have the actual triangles listed in them.
Are those straight lines? It's like between the points?
So they are azimuth measurements. So just left to right, not vertical. So a spherical triangle does have a vertical component to it. But they are not measuring that particular vertical component. And there's a way to use, so it's not a chord. A chord would be a line between 2 points, ignoring the curve of either a circle or a sphere. They are along the curving surface of a sphere.
Okay.
And let's see what page was. Got to get the right page.
So you're saying if I went out onto Mille Lacs Lake and plotted 3 points that were equally distanced from each other.
They don't have to be equally distanced.
They don't?
No.
Okay. Well, to keep it simple for my little brain, if they're equally distanced from each other, then you could have a triangle that would have equal angles, right? On each three.
Yeah.
Yeah. So you're saying that that doesn't work on a flat surface?
On a flat surface, the triangle would sum to 180 degrees. It'd work perfectly fine. If the Earth were flat, the sum of those angles would be 180 degrees.
And if it was curved,
It
some
would
of
be
those angles
more
would be,
than
it would be
the
more.
sum
Okay.
of them would be necessarily. It has to be.
Okay. So you, on a spherical shape, like we could do this with a basketball too, right? I mean, technically we could plot these points on a basketball
absolutely.
and get
And
the
then
same measurement.
the
Okay.
beautiful thing, you could use, see this formula right here, cosine C over R. You could use that formula, solve for R, which I have here in this, I won't go into it, but you can look on my website, mc2.net/SE for spherical excess. And all you need to do is plug in the angles and the sides, and it tells you the radius of the object you're on. So here's a challenge for you. We'll do it maybe when when I come on yours. You get a ball. Don't tell me what it is. Don't tell me what type of ball it is. All you need to do, I'll give you instructions. Draw some lines on it, or use string and measure the angles and distances. Then you tell me that, and then I will tell you the radius of that ball.
Okay.
Anyway.
And how does that prove that the ground is? I'm just teasing you. I'm just teasing.
Because and I have several surveys right here. 1, 2, 3, 4, 5 different surveys. Each of these surveys has many, many spherical triangles in them. Right, so this one here says, I even made it easy. Starting on page 22 of the California-Washington Arc of Primary Triangulation from 1913.
So what are the angles
I'll show you.
on a sphere, like what are the internal angles?
Oh, my computer's not. Come on, there we go.
I think I'm missing out on something
so,
here.
Yeah, so
I'm not understanding.
I'll show
something.
you. Come on. It's
because I think that if you have a triangle on a sphere, that it just wouldn't sit flat on the sphere.
Yeah,
like
on the surface of a sphere, the lines are curves.
Yeah, they're curves on a sphere.
Yeah.
But if it was on a flat surface, you'd still have the same triangle, and there just wouldn't be curves.
Yeah. But the thing is,
and you're saying that we can measure curves.
No, we're just
right?
all we're measuring is the azimuth. We're not measuring the vertical part of it. So
okay.
So this even though there is a vertical component to it, these measurements don't include that. They don't need to. So right here I have
I took over Simon and Dan's old office,
Nobody, because I'm sharing this, nobody can see what you're doing yet.
Oh, okay, good.
So sorry.
No,
right.
That's fine.
So here is one here. This
right.
top one. The zooming in a little farther. They have these points, and you can read the book where it talks about where these points are, gives physical description of where they are. So Bolivar, Spur, and Bally are the different points that they measured in this one particular triangle. You can see the spherical angles, 101 degrees, 25 minutes, 28.13 arc seconds. Add them up, and you get more than 180 by 8.67 arc seconds.
Okay.
Next one has a spherical excess of 4.74 arc seconds. The spherical excess is the amount more than 180. So all of these triangles have more than 180 degrees in them. On and on and on. Every one of these do.
And these are, I guess I can't really tell by looking, but these are what kind of measurement are they using? Is it like, how far of a distance, I guess is what I'm saying.
This particular one doesn't list the distances. The other ones, some of these other ones do include the distances, but here's the beautiful thing. I took the distances, I took the formula, I took the angles, and I plugged them into a spreadsheet where I put the formula in. So here is number 1, and these are the distances in meters.
Okay.
8,687 meters. So 8 kilometers.
So Okay, so they're quite the distance.
Yeah.
Okay.
That's side A. Side B is almost 14 kilometers. Side C
Did
is
they
11
figure in
kilometers.
refraction when they were
The beautiful thing about this is because it's an azimuth measurement, refraction doesn't affect it. A refraction affects the vertical because there's a vertical
was it a
gradient.
visual? But what? No,
Yeah.
I understand what you're saying because you're not doing vertical, measuring vertical. But if you're looking through a medium
Yeah.
that's unpredictable, and you said they were shining lights or lighting fires
Yeah.
or like that idea, couldn't that just have been easily off as far as the curvature to get your?
No,
do you know what I'm saying?
Yeah, I know what you're saying, but because it's an azimuth angle instead of a zenith angle, it's not affected by refraction the same way because there isn't
I'm not saying it would be the same
horizontal gradient. There's a vertical gradient, but not a horizontal gradient.
Well, if you're going 8 kilometers, there's definitely a gradient as you move through the horizontal. It's not going to be all the same.
Yeah. But it's
because you have wind. I mean, like when,
and that's and high wind can affect it, and that's why they do it many times. And then
that's why I look across the lake many times.
They do the statistical analysis, and if they have outliers, then they'll do more, right? If their margin of error or their standard deviation is too high, they'll keep going so that they get a very tight standard deviation.
Okay.
Right? So
I got you.
This is surveying. So let me finish though, right?
Okay, I'm sorry.
So there's the lengths of the sides, and then we have the degrees, minutes, and seconds of the angle A, angle B, angle C, and it gives right here we have the spherical excess. In fact, the book lists it, and I'm confirming that my calculations got it correctly and that they're in agreement. And then I use that formula that Dr. Clive proved, and plug it in, giving a radius of 6,432 kilometers. And you see there's 3 of them because the formula actually just uses one side. So what I did is I calculated it using all 3 sides, and then I get a mean here, 6,432, 555.65 kilometers. Now here's the cool thing.
For the radius of the
radius of the Earth, right?
Okay.
Now, if horizontal refraction or horizontal things were messing it up, then you'd get a wide variation in these results. But you know what you don't get? You don't get a wide variation in the results. You get over and over these different spherical triangles in different locations over huge distances.
You're saying they're consistently the same.
Yes. Repeatability is an important part of science, is it not?
Oh, it is.
Now, it is tedious to type these in. So I haven't typed in a lot of them. Just a second.
Can I ask one question?
Almost done.
Okay.
All of these average, and here's the average of this particular set that I've put in so far. This assumes absolutely nothing. It doesn't look at the sky. It doesn't assume that the Earth is spherical and like Eratosthenes does, right? It makes 0 assumptions. It just measures these triangles, finds that there is a spherical excess, applies the trigonometry to calculate the radius of a
approximate size of the sphere.
And they come up every time with the same radius.
Okay,
go ahead.
The question I had was, when, like how current or recent are these measurements? Just out of curiosity.
These
not that it matters.
Tend to be from the early 1900s because after that, so we had the early 1900s, World War I, people weren't doing this. In between, Depression, people weren't doing this. World War II, people weren't doing this. Then we started sending up satellites and measuring things differently.
Yeah.
So, but they've had the accurate radius of the Earth measurements since.
What if the Earth was changing? What if the Earth was changing? I mean, just in the last 5 years, what if the Earth was actually changing?
The massive quantity of earthquakes would tell us that.
Are you sure?
Yes. PhD Tony, an expert in earthquakes. If the Earth's shape was changing drastically, Tony, would we notice? But since we use satellites to measure the shape of the Earth,
What if
it's
the maker was changing it? Will we notice then?
again, yeah, it's a.
Just saying. I'm just saying.
If he was deceiving us, then yes, all bets are off.
No, I don't think he's deceiving us, because when I look across, here's what I kind of, with the consistency of the measurements, like you're saying, that these triangle measurements come up consistently pointing at a certain size radius, right? And I acknowledge that. I have no problem acknowledging that. But like, just for an example, that's kind of a competitive example to that, is when I look across Mille Lacs Lake, most of the time I can just look across and see the other side when it's pretty calm. But if it's windy out, I can't see the other side of the lake. I can't see the trees or the water towers on the other side of the lake.
Yeah.
But consistently, though, I just look across and see the other side.
There's a lot of variation.
Yeah, there is. Yeah. And so that's what I'm saying is,
it's not a great way to measure things because it's affected by uncontrolled variables so much.
But if I told you I was seeing do you guys see I got Simon Dan's office now?
Yeah, I see that now, yeah.
Yeah. Do you guys see I was also I had to fill in for Neil Armstrong one day. I'm just kidding.
That's before you were born.
Oh, you think I'm that young? I'm just kidding.
I don't think you're over 50.
I'm not. I'm 43. 43.
I'm 13.
What's that?
I'm 13.
13. I saw that. You just had a birthday, didn't you? Happy birthday.
Yeah, thanks.
13's a tough 13. One though.
Yeah, I'm
hope you got some good friends.
Yep.
It's a tough time in a young boy's life.
Let's see. Gary IOW has some questions about senses.
I do too. I have some questions about.
Oh, hold on. I got to do this first.
Okay.
Harry 7 says, "Do parallel lines have opposite slopes?"
I think parallel lines. All I know about parallel lines. That's what I have to preface it with. All I know about parallel lines is that they're parallel.
Okay. It'd be, yeah. So they're saying to help you visualize, have somebody at the top of the IDS tower.
Okay.
Somebody on the top of Mall of America.
Okay.
And then somebody on top of the I don't know if you get down to Bloomington enough, but there's some tall buildings on the west side of Bloomington, the 8400 tower.
Yep.
Get on the peaks of those three and measure, just stand on the peak of the IDS tower and measure the angle between Mall of America and the 8400 tower. Just that angle, right? Okay. Then do the same from the other locations.
The other two.
That's how you get those spherical triangles.
And so you're saying the refraction doesn't have a big effect on it because you're not looking up or down. It's not a
zenith. Yeah, because the density in the atmosphere is vertically stacked, not horizontally.
Yeah. So as you look higher and higher, you get a clearer view. Basically, you're looking through less refraction.
Well, it's not because you're higher. It's that because there isn't a left to right gradient.
Yeah, but if you look straight up, the gradient, it goes up above you, so you end up. Sorry if I'm looking over here. I got my laptop over there, or my other laptop, but I understand what the gradient is. I understand, I think in general, most of the ideas that we're talking about, and if I had to weigh that out, okay, so we can get an angle and an angle and an angle from those 3 points that you just were saying in Minneapolis or the IDS and the Bloomington and wherever. We could do that, and we come up with not a 60-60-60 triangle or whatever angles they were at.
It sums to more than 180 degrees. Yeah.
Yeah. So it's like 100 and whatever, but it's more than it would be if you were just drawing it out on paper.
Yeah.
The angles. And so there's something there, and I'm not gonna not acknowledge something that people have obviously measured, like some people might tend to do. But what I to explain that that's curvature is really hard for me to I just that's not in it doesn't seem right to me because um of exactly what we've been talking about, refraction, and we're looking through a medium of air. I mean, if you're on top of the IDS, you're a little bit thinner of air. I guess what I'm saying is, I just when I
You
look,
just don't get it.
no, when I look a certain distance and I see uh, a tree line across like Mille Lacs Lake, I see a tree line that uh, the surface of the lake. I'll do that. There's no horizon on the surface of the lake, no matter if you're at 20 inches on a calm day when it's not windy. If you're 20 inches above the surface or if you're 6 feet above the surface, there's no water blocking you from seeing the water behind it. You just see all the way to the other side.
Of course, that is predicted on a globe. It's also predicted on a flat Earth.
That's what I would say.
Not
Is it
a useful measurement?
Well, it's actually a very useful measurement. It's just an observation is what it is. It's just an observation that we can see things straight ahead of us, right? And to say that the ground is curving away, obviously something that we can't really come to an agreement on, I don't think, because you're going to say that no matter how far we're looking, that refraction, the air we're looking through is enough to make it look flat while it's curved. And what all I'm saying is that I'm starting out in my mind, we're flat. And if I like left to right, that's one thing Rhetoric was talking about in Fight the Flat Earth, that debate. He was saying I think it was Mick West, maybe someone took some pictures of chess pieces on top of a car.
Yeah,
did you see that before?
Yep.
And to me, that his argument there was really flawed because he's just using just the camera view, and there's left to right there's two chess pieces. Well, then when you go over to the side, you see that they're curved, right? It appears straight in that picture, but if you're at the ocean, and I can put that behind me again, if you're at the ocean, it's not like we have behind me right now. You have a limited view left to right, but you can turn your head left and you can turn your head right and you see much, much further, and it's still a straight line is what I'm saying.
Yeah. Tell you what, I will bring measurements of the curve of the horizon at low elevation.
Okay.
But we're over 2 hours. We should move on.
Yeah.
And get wrapping up here.
Sure.
Joe, it's great to talk to you. People have said it's nice to have a level-headed conversation. I appreciate that.
I appreciate it too.
The dumpster fires have their own je ne sais quoi.
Well, I do. Oh, go ahead. Go ahead.
But I think it should be ideally it's better to have conversations that are level-headed. So I appreciate that.
I agree. And I would comment on, the chat, the vibe going on in the chat in a lot of these is, to me, it seems like a lot of people with some of the comments they're making are doing a disservice to themselves. Whether, like, I'm not going to convince you that the earth is flat. Like, that's not the reason why I even would talk about it. It's to open you to some, maybe, and I'm not saying they're right and you don't have to believe they're right, but there are other ways of thinking of some of these things is what I've been learning, that I've been learning to look at them in a different way. And some of the things explained to me that we've been maybe looking at this wrong. We've been born into a time that the whole world's been looking at this wrong. But
okay.
I'm reading the chat now. Sorry.
Okay. I saw that Brenda is here too, and I think if it's the Brenda I'm thinking of, it's another Minnesota, Minnesotan would be the right word. So, well, like I said, I'll be in your channel here. I'll post it on my Discord, and so I don't know, probably do a
Sounds good.
community post.
We'll have fun. We'll have fun because I'll be able to maybe give you a little bit more understanding into the reason why I strongly believe.
I think we all kind of know why you strongly believe it.
Well, I mean on like a more of a specific level. So if you guys are interested in the biblical reason, like that side of the story, that to me, that's more of a convincing, that's just personally, it's more of a convincing story than I could get from, doing an experiment or something. It's more powerful to me than that. So, but if you're interested, I will be doing a live stream sometime soon here with Tune, and we can maybe get into a little bit of that fun stuff.
All right. Well, thank you, everybody. I'm going to do an after show here. You can join in the chat if you want, EftupWorld, or
maybe I will.
So a couple, I did send out a couple things to people, but so far nobody's said yes. So if you're interested in joining, send me a message on Discord or Facebook or email. So thank you for joining, everybody. Thank you for super chats and members and patrons. I appreciate everything you do. Be looking out for next week. I sent an email to Gary Wybenga, hoping to get him to come on next week. We'll see if he does. So thanks, everybody. And get this right. All right. Bye.